Hey everyone, how are you all? Hope you all are doing well with your best of health. This is Sham. In this video, actually, I bought two measuring instruments called Vernier caliper and screw gauge. We'll discuss one by one. Before entering to that part, I want to tell you a few more facts about the measuring instrument day-to-day life we are using now, like a meter scale. From here, we'll start. Basically, we know that meter scale means it will measures in terms of centimeter. Correct my point. What is our least value which we can measure from this meter scale means what you will do. So basically you will go with the 1 centimeter division here. In 1 centimeter, how many divisions are existed? 10 divisions are existed. Now in that 10 division, coming to below a diagram here, this is what actually I was marking now here in a below one. Okay, this is the least value which it can be measured, right? This is actually basically we know that it is a 1/10th part of complete scale, means complete that 1 centimeter, means the least value which you can measure. I can call this one as a least count. It is nothing but 1/10th of this centimeter scale. So that 1/10 means it will gives here 0.1 centimeter. This is a least value which we can measure from this meter scale, right? Next, if we're going to read the values, okay, 0.1 is a least value, means I can go with here was after 0.1 centimeter, it's 0.2 centimeters, 0.3, 0.4, 0.5, like that. Okay, what if the measured value will be exist at this point? Look at my cursor at this point. If it will be exist means, is it possible to measure exact value? Either you will go with here the reading 0.6 centimeter, or else you might be take 0.7 centimeter, but it is actually not correct now, because you can't take the value at when it is at the middle 0.6, right? And by using this meter scale we can't measure that precious value after 0.6. Might be we will get here 0.61, 0.62, 0.63, like these values, but these values unable to read from this scale, means after decimal the number of digits will be increases, means that value is most actually accurate, we can call, correct now. That accuracy we are unable to reach from this meter scale. So that we will introduce two scales here called vernier caliper and screw gauge. If in case vernier caliper, the value what I told now 0.63, after this decimal we can reach up to 2 digits. Okay, if you want further more actually accurate value, you can go with screw gauge. Screw gauge will give up to 3 digits accurate answers. So that for these two purpose we are using the vernier caliper and screw gauge, just because of in order to get accurate values where actually we are unable to reach out from the meter scale. Next, we'll discuss one vernier caliper here. Basically vernier caliper will be look like this. Okay, in this vernier caliper, here look at this one. These two are called upper jaws, these two are called lower jaws, and this is the scale which will be reads like a what we call meter scale. Okay, this is we called in this vernier caliper main scale. What we call this one? Main scale. And here one more scale is existed, correct now. We call this one as a vernier scale, right my point. And here you might be saw two jaws, right now we can call this one as a jaws. Okay, this is called lower jaw, this is called upper jaw, upper jaws. Okay, this lower jaws are used to find out the outer diameter of the object. For example, this is a pen, these two are the jaws. I will place this pen at this point and I will fix this one like this. From here actually I can measure the outer diameter. Okay, my point. And upper jaws are utilized for calculating inner diameter of the objects. For example, there is a spherical object. I will place that spherical object over the jaws, and the jaws will be fitted inside. These are the two jaws. These are the two jaws. Here I place this spherical object, and these jaws will be clipped like this. Means then basically we can calculate inner diameter. Okay, and then how to calculate the least calculation or least count of this scale means we can calculate here. For what we need to do means simple. Here might be you see, okay, this is called main scale. This is called Vernier scale. Okay, in order to calculate the least count, we need to follow one formula here. That is, least count will be equals to 1 MSR, means main scale reading, minus 1 VSR, means 1 Vernier scale reading. Clear my point? After this, 1 MSR means generally we can say like that. Okay, for example, this main scale division, one main scale division will be equals to, for example, I will take here 0.1 centimeter. Okay, it can measure up to 0.1 centimeter, I can say. Okay, and then VSR value we need to calculate like this. For example, look at this figure properly. In this figure, basically, look, this is Vernier scale divisions, this is main scale division. Okay, now here from 0 to 10, these digits are Vernier scale divisions. Okay, these 10 digits are fitted in main scale only for 9 divisions. Look here, up to here it is 10. From 0 to 9 division of main scale readings are coinciding with here 0 to 10 of Vernier scale. So that we need to write this one in this pattern. How? For example, in this case, 10 Vernier scale readings or divisions are equal to 9 main scale divisions. Okay, here one Vernier scale reading will be equals to 9, 10 will comes to here, 10 main scale division or reading. Okay, now put this value over here in order to calculate least count. Correct. Now if I'll take that value directly here, so for example, least count will be equals to 1 MSR minus 9 by 10 of MSR. Correct. Now MSR take common, so it will become 10 minus 9 by 10. It is nothing but 1 by 10 MSR. This is what least count. After this, you need to substitute the value of MSR. For example, I told here MSR value is 0.1 centimeter. Put that value over here, so that the least count you'll get here 0.1 into 0.1 centimeter. It is nothing but 0.01 centimeter. This is what actually the least count of this screw gauge. This is how you need to calculate the least count of the given screw gauge. Hope it is clear. Okay, now next we'll solve problems based on that. Meanwhile, okay, after calculating how to measure the values, this is what actually important, right? Okay, here look at this screw gauge, sorry, Vernier caliper. Here I placed one nut. After enclosing that two jars, now actually this is main scale. Okay, main scale is after 10, it reaches some values here. Just take a value, whatever the value it is, and then this is MSR reading. We call this reading as main scale reading, and then we need to later check which actually Vernier scale division is matching to Vernier main scale. For example, from here I will take an example only. Here I can't unable to match anything. Okay, this is the line which is matching. Okay, which line is matching? Actually, we need to take that value. That value is known as Vernier scale reading. Okay, and later on we need to put these two values in this equation. What is the equation in order to calculate reading? Means here main scale reading, that is MSR. The reading value can be calculated by MSR. Okay, main scale reading plus, yeah, and then VSR, Vernier scale reading. That Vernier scale reading you need to multiply with least count. Okay, then you will get to know that what is the reading of the object. Let's discuss one by one, then you'll understand while solving the problem how to measure this all the values. Okay, next, for example, here general equations here. So if n divisions of Vernier scale coinciding with n minus 1 division of main scale. Then find out the least count, I will ask. Now least count means we got to know that 1 MSD minus 1 VSD. This is the formula. So least count will be equals to 1 MSD minus 1 VSD. Correct now? Here we don't know the value of VSD, right? So that what we need to do, what actually in the equation given, we need to write the same thing. N division of Vernier scale divisions. N VSDs are equals to N minus 1 MSD. Correct now? And then 1 VSD value will be equals to N minus 1 by N MSD. Correct now? This is what 1 VSD value. Put this value in this equation. For example, least count will be equals to 1 MSD value as itself. I will take MSD common because after substituting VSD, here MSD will become common, minus N minus 1 by N into whole MSD. Multiply this answer here, N minus 1 divided by N MSD. Correct now? And later on, if I multiply inside, minus n plus n will be cancelled, minus into minus plus 1 will come. So the least count will become here 1 by n times the MSD. If in case they will say like that 1 MSD value is 1 centimeter, put that value 1 centimeter over there. That is your answer. Correct now? Based on in this pattern, we need to calculate least count. Let's calculate few more. Before that, actually, when you will place the two jaws, okay, when they will be touch each other, at this time, if the 0 of the main scale is exactly coinciding with 0 of the Vernier, at this condition, there is no zero error. Means instrument is working super cool. There is no problem. Okay, at this condition, we can directly take the values and we can measure everything as of now how we did. What if in case the main scale division, look here, main scale division 0 is here, Vernier scale division 0 shifted in forward direction. Look at this one, basically 0, this is 0.5 millimeter means 4 millimeter, 3 millimeter, 2, 1, means somewhere else it is existed here, means in x-axis or else in this direction it is shifted by 0.5 millimeter. Then this answer actually having extra value initially itself. At this condition, we call this one as a positive error. So that what we need to do means we need to calculate reading as usually. Reading will be equals to MSR plus VSR into least count. Okay, this extra 0.5 is added in this equation right now. So that we need to subtract this answer. We call that one as zero error. Basically, the value is positive here. It is extra. So that we need to subtract this value. Look at this positive error. When 0 of the Vernier scale is to the right of the main scale is 0. Main scale zeros, right, or else forward. In this condition, the value, how much we will get here, 0.5 millimeter, we got now, that value we need to subtract with the total. Clear now? This is for positive error. Okay, negative error means basically here, look, this is main scale, this is Vernier scale. Now 0 of the Vernier scale is actually behind the 0 of the main scale, means it went negative axis. So that here the same value I can write, for example, x is equals to, I will write where I will write here x is equals to minus 0.5 I will write, because from the main scale it went backside. Correct now? So that answer whatever we will get now, it will be shortened by 0.5 centimeter. Correct? For that reason, after getting reading will be as usually same, MSR plus VSR into LC. But in this case, answer is very lesser than the original answer, because actually it went backside now. So that we need to add here plus zero error, zero correction. We call this one as negative error. Correct now? This is all about actually Vernier scale. Let's discuss numericals one by one. Here first question is, I'll discuss the question here. The first question here, it is saying, what is that? The specific Vernier caliper of 10 division of the Vernier scale coinciding with 11 division of the main scale, they are saying. For example, here 10 division of Vernier. Here it is 10 divisions. Okay, of Vernier scale are coinciding with 11 digits of, what is that? Main scale, they are saying. Don't be think about like that. That figure is not matching to the equation. Just I'm taking here, that's all. Okay, we need to calculate least count. For least count, we have a formula 1 MSD minus 1 VSD. Right, my point. 1 MSD value they given 1 millimeter. So that we need to calculate here least count. Least count formula we got to know that, but 1 VSD value we don't know now. For that reason, what all we need to do means, basically they said here 10 division. Just a minute. 10 division of Vernier scale reading are matching with or coinciding with 11 main scale readings. Correct now? So that 1 VSR means 1 Vernier scale will be equals to 11 by 10 MSR. So that we can substitute this value in the above equation here. On substituting over there, least count will be equals to 1 MSD. I will take MSD common here. MSR, MSD, there is no problem. Okay, main scale division. Here I written main scale reading. That's all. Minus 11 by 10. From both I took common MSR. It will become 10 minus 11. It will be minus 1 by 10 MSR. So that 0.1 along with minus. Okay, MSR reading is nothing but 1 millimeter. Put that value here, 1 millimeter. Hence, you will get the answer minus 0.1 millimeter. It is your answer. So, correct option is option B. We'll discuss few more questions like this. What is the least count of the Vernier caliper if 10 division of the Vernier caliper coincide with 9 division of the main scale? What they are giving, we need to write, that's all. First, what they are saying here, 10 division of Vernier scale readings are actually equal to 9 divisions of main scale reading are divisions. Then 1 VSR value will be equals to 9 by 10 of MSR. Then what we need to calculate? We need to calculate here least count. Least count formula is again 1 MSR minus 1 VSR. Correct now? What is 1 MSR value? It is a standard. They are given 1 millimeter. We'll write this 1 VSR value here. 1 VSR value here, 1 MSR minus 9 by 10 of MSR. Correct now? Take MSR common. 10 minus 9 by 10. It is nothing but 1 by 10 of MSR. So that we'll receive our answer 0.1 MSR. What is MSR value? Here it is 1 millimeter. Multiply that one here, 1 millimeter. What is the answer you'll get? 0.1 millimeter. So correct answer is option B. Like this, we need to calculate least count. We'll discuss one more question. While measuring the diameter of the rod, it is come. Now actually the question came real questions here. Because the least count is done. Now we need to calculate actually the total reading. The diameter of the rod, the MSR value is 2.5 centimeter. Main scale actually it is at 2.5 centimeter. And fourth Vernier is division coinciding with the main scale. Fourth Vernier means it's a Vernier scale reading. The least count is 0.01 centimeter. They given already. No need to calculate least count in this point. Find the diameter of the rod. Now diameter is nothing but the total reading of our question. It is nothing but MSR plus VSR into least count. Correct now MSR, it is nothing but 2.5 centimeter. Substitute that value here. 2.5 centimeter plus VSR value, that is fourth vernier is actually coinciding, they told. Substitute that value here, 4 into least count. What is the least count here? 0.01 centimeter. Okay, multiplied means it is completely in centimeters. So find the diameter, means now the value we need to calculate. 2.5 centimeter plus it will become 0.04 centimeter. So that answer will become here 2.54 centimeter, right? So correct option is option B. Then I hope you have understood this one, right? Next, a caliper has a least count. They given least count directly. Correct now. When jaws are closed, the zero of the vernier scale is right to the main scale 0 and third division coincide. Now actually that main scale to the main scale vernier scale move forward, means positive error. Which line is actually matching, means that's it third, means we can take the zero error as a positive. Okay now, that is plus third line. Okay, each line measurement is actually 0.1 millimeter. That is what actually mean least value. So that I can write here 3 into what happened, just a minute. Okay, one more time. Least count is 0.1 millimeter. Jaws are closed. Vernier scale to the right of the main scale 0 and third division is coinciding. Means least count they given here 0.1 millimeter. And that third division is coinciding, means zero error is positive. That value is third division they said. Third division means here 3 into each division value is 0.1 millimeter. So we need to write here 0.1 millimeter. So that zero error will come here 0.3 millimeter. So that final answer we need to subtract with this. So then next, the while measuring sphere, MSR value they given 3.2 centimeter, and then seventh division is coinciding. Coinciding division is seventh one. What is the corrected diameter they are asking? So that reading will be equals to MSR plus CVD into least count, and then we need to subtract the zero error. Correct now? MSR value how much they given? 3.2 centimeter plus CVD is seventh division is actually coinciding into least count. Least count of this division will be 0.1, that is in centimeter, minus it is 0.3 millimeter. Correct now? And then it will be 3.2 centimeter plus 0.7 centimeter minus this is 0.3 centimeter, 0.3 millimeter. So that we need to write this in terms of actually what is that, centimeter. So that it will become 0.03 centimeter. So it is 3.2 centimeter plus 0.7 minus 0.03. Look, 0.7, 0.03. Correct now? So 10 minus 3 means it is 7. So it will be 6. So answer is 0.67. Substitute that value here, 0.67 centimeter. Correct now? So finally, what you will get on adding these two, 3.2 plus 0.67. The value is going more than that. Is there a mistake we done? I think we connected with some mistakes here. We made a mistake here. Actually, it is 0.7 into 0.1. It is in millimeter and minus 0.03 centimeter. Correct now? And then nothing. Everything is done right. Exactly. This 0.7, it is in millimeter, but if we'll convert this one to centimeter, means 0.07 centimeter, and then 0.3 in common centimeter. And subtracting these two, 0.04 centimeter, and adding these two, you'll get here 3.24 centimeter. Hence, correct option is D. Right. We'll go with the next question. What it is saying here in this question means the main scale of vernier caliper is n division per centimeter. N divisions per centimeter. Okay, n divisions of the vernier scale coinciding with n minus 1 division of the main scale. The least count is. Now, look at this one. Least count means again the same formula. Least count will be equals to 1 MSD minus 1 VSD, or 1 MSR minus 1 VSR. Basically, we don't know the value of VSR. How to calculate VSR means how many divisions are connecting. Just look at there. N divisions of what happened. Okay. N division of vernier scale readings are connecting with n minus 1 division of main scale readings. Correct now? So that 1 VSR value will get here n minus 1 divided by n MSR. Substitute that value here. 1 MSR minus n minus 1 by n MSR. From both I can take MSR common and multiplying n here, n minus n plus 1 divided by n into MSR. Correct now? So plus n minus n cancel. 1 by n times the MSR. But here, look, MSR value we are not yet defined. Basically, in order to calculate MSR, what all we need to do means, here they told n divisions are present in 1 centimeter. Means main scale readings are here. Look, like 1 centimeter. I can write here like this. Wait, I will tell you. Look at this one. N divisions are present in 1 centimeter. Means main scale readings are 1 by n of the centimeter. In 1 centimeter, n divisions are there. This is what actually main scale reading, right? Put that value here so that you will get here 1 by n. MSR value is 1 by n centimeter. So that your answer will be equals to 1 by n square times centimeter. So option B is your answer. Then next, a spectrometer gives the following reading when used to measure the angle of the prism. Okay, the MSR value is 58.5 degree. VSR value is 9 divisions. Given that one division on a main scale corresponding to 0.5 degree, the total deviation in a vernier scale is 30 and matches to 29 division of the main scale. The same kahani. Okay, 29 divisions of main scale are matching to 30 division of vernier scale. We can write 30 VSD is equals to 29 MSD. Means 1 VSD value will become here 29 by 30 MSD. Correct now? So that we can calculate least count from here. Okay, least count will be equals to 1 MSD minus 1 VSD. 1 VSD value substitute here. So that least count you'll get here 1 common. I will take MSD. VSD value means it is 29 by 30 MSD. So that you'll get here 30 minus 29 means it is nothing but 1 by 30 MSD. What is main scale division basically? Did they give an answer? Main scale division, not yet, as I guess. Here, look at this. One division on a main scale corresponding to 0.5 degree. Means MSD is nothing but 0.5 degree. So least count will be equals to 5 degree by 30. Or else 5 by 30 degree. Okay, this is the least count. Now we have to calculate the reading. Reading means as usually MSR plus CVD into least count. Correct my point. MSR, how much they given here? 58.5. 58.5 degree plus CVD. CVD is nothing but I written here CVD VSR. Sorry, it must be VSR. Okay, VSR value, how much they given? 9 divisions. So I will put that value here. Okay, 9 division into least count. Least count, it is 0.5 degree. Sorry, it is 0.5. So you'll get here 0.5 degree divided by 30. Correct now? So on cancelling this one, it will become 1 by 60. 1 by 60. So answer will be 58.5 degree plus 9 into 1 by 60. Correct now? That is also in terms of degree only, the complete value. So if the 10 you take outside, it will become 3 by 2. Okay now? I can write this one as like this: 58.5 degree plus 3 by 2 into 1 by 10. 3 by 2 means 1.5 and divided by 10 means it is nothing but 0.15. So that you can write here 58.5 degree plus 0.15 degree. And combining this one, you will get here nearly 58.65 degree. Option C is matching. Correct now? This is how you need to calculate. Degree means, as usual, whatever the values they will give now, we need to substitute that values here. That's all. Next question. 1 centimeter on a main scale of a Vernier caliper is divided into 10 equal parts. 10 division of Vernier scale is coinciding with 8 divisions of main scale. Then the least count. They are saying here 10 divisions of Vernier scale are equating with 8 main scale divisions. So 1 VSD value will become here 8 by 10 MSD. Correct? Now calculate here. Least count will be equals to 1 MSD minus 1 VSD. 1 MSD, MSD we can take common. VSD value we need to write here 1 minus 8 by 10 on both common MSD. So 10 minus 8 means it is nothing but 2 by 10 MSD. MSD value, how much they given? 1 centimeter main scale of a Vernier is divided into 10 equal parts. Look, 1 centimeter divided by 10 equal parts means the least count will be, or else the least value it can be measured is 0.1 centimeter. Means main scale division is 0.1. So it will become 0.2 into 0.1 in terms of centimeter. So answer will be 0.02 centimeter. So option B is correct. Okay now, next one. A Vernier caliper has a 1 millimeter mark on a main scale. It has 20 equal divisions on the Vernier scale with a match 16 main scale divisions. For this Vernier caliper, least count, again same, least count will be equals to 1 MSR minus 1 VSR. Correct now? VSR value, how to calculate? They only told here 20 Vernier scale readings are matching to 16 main scale reading. So 1 Vernier scale reading should be equals to 16 by 20. Something happened here. 16 by 20 main scale reading. Correct? Put that value here. So that 1, I will take MSR common minus 16 by 20. On both common here it is MSR. So that 20 minus 16 means 4 by 20 MSR. 1 main scale reading, it can be read here 1 millimeter. So put that value 1 millimeter. So that here 4 ones are 4 fives are 1 by 5. It is nothing but 0.2 into 1 millimeter. It is nothing but 0.2 millimeter. Option D. Right. Next question. A student measures the terminal velocity of the steel ball falling through a viscous medium. He uses a Vernier caliper to measure the diameter. MSR value they measured here 0.5 centimeter, and 8th division of the Vernier scale is coincide with the main scale. Least count value this much. Zero error also they given 0.02 minus. We need to add this value then. The correct diameter. Then it is simple. Reading will be equals to MSR plus VSR into least count minus of minus zero error 0.02, that being centimeter. That's all. We need to put the values here. We'll get the answer. For example, here main scale reading they told here 0.5 centimeter plus VSR value. Which line is coinciding? 8th line is coinciding. The least count they given here 0.01, that in no centimeter, minus half minus means it will become plus 0.02 centimeter. So that 0.5 centimeter plus it will become 0.08 centimeter plus 0.02 centimeter. On adding these two, it will be 0.1. 0.1 plus 0.5 means it is 0.60 centimeter. So option is B. That's all. This is all about actually the Vernier caliper slides. Okay, hope you all understood, and thank you for watching.